Hi, in this video, I'll be answering this question that I got from one of my students in a calculus class about hyperbolas. The question is where B is on the graph. If you just come into this question like this, you may be a little confused as to what the context of it is. What the heck is B? The context of this is that we're talking about the standard way of writing the equation of the hyperbola. And in this video, I'm going to talk about the hyperbola centered at 0, 0, so we don't have to worry about the h and the k. So these are the standard way of writing the equation of a hyperbola as taught in a typical calculus or pre-calc class. The first equation is the equation of a hyperbola that opens left and right, that opens along the x-axis. And the second form is a hyperbola that opens up and down. So the two branches cross the y-axis. And the way you recognize the equation of a hyperbola, in the first equation, you have a plus x squared but a minus y squared. And in the second equation, you have a plus y squared but minus x squared. The value a that comes with the positive term, it shows you the distance from the center to the vertex. So if the center is at 0, 0, a and minus a are the two vertices. And it's the same thing whether or not it's opening on x or opening on y. So let's take a look at the graph. Here's a hyperbola that opens on left and right. It has positive on the x squared. And the value a here is the distance from the center to a vertex. That's where a is on the graph. When the center is at 0, 0, the coordinate, the x value here is a, and the x value there is negative a. A is the distance from the center to the vertex. But b is not clear where b is on this graph. Now let's take a look at a hyperbola that opens up and down. Positive is on the y squared, and a is still the distance from the center to the vertex. So the y value here is a, and the y value at the vertex at the bottom is negative a. No b's. And that's a totally unfair situation, especially if you compare with the ellipse. You recognize the equation of ellipse by seeing that both x and y are squared, and both x squared and y squared terms are positive. In this case, a is right here, and b is right there. A is the distance from the center to the x vertex, and b is the distance from the center to the y vertex. Very straightforward. You can see a and b on the ellipse itself. So that's the context for the question that we just saw. Where is b on the graph of a hyperbola? The answer is b is not on the curvy hyperbola itself, but it relates to the asymptotes of the hyperbola. Right? A hyperbola comes with a pair of straight lines, the asymptotes, that are kind of guiding the curviness of the hyperbola. How does it work? Let me take away the asymptote and I'll show you. Here's the hyperbola x squared over a squared minus y squared over b squared equals 1. We know it opens horizontally on the left and right because the x squared term is the one that's positive in standard form. And we know that here's a, and here's negative a, and the distance from the center to the vertex is a. I'm going to use b to find the asymptote. From the center, I go with distance of a, I get to the vertex. If I go off of a vertex by a distance of b, up like this by a distance of b, then I will have my asymptote. That's my asymptote. Yes, correct. The slope of the asymptote is the ratio of, you take the y denominator and you take the square root of it to get to b. So the square root of the y denominator divided by the square root of the x denominator. In this case, it's b over a. So you see a on the graph as the distance from the center to the vertex. And then you see b on the graph as the distance from the vertex go up until it hits the asymptote. That's b. Let's do it again with a hyperbola that opens up and down, where the positive term is the y squared term. A is the distance from the center to the vertex. The y value here is a, and the y value here is negative a. And then from the center to the vertex is a. So if I go off of the vertex by a distance of b, I will hit the asymptote. So if I go over here by a distance of b, then I will know that that line is the asymptote of the hyperbola. And sure enough, there it is. And the slope in this case is a over b, the y number over the x number. A over b is the slope. All right, so in summary, if you go from the center, a distance of a, you get to the vertex. And the vertex is on the hyperbola itself. And then you go a distance b off of the vertex, so you actually go off the hyperbola. Then that will get you the asymptotes. The distance b itself is not on the hyperbola, but it's part of the asymptote, and the asymptote guides the curviness of the hyperbola. All right, hope that helps. Like, share, and subscribe for more contents. And thanks for watching. Bye.